So I'm Patrick Cousins. I guess I already got an introduction. I work at Etsy, but I also run a meetup right here in Brooklyn called KotlinCon. We're always looking for speakers, so I just want to call that out really quick. If you would ever want to speak at a meetup, hit me up on Twitter. So today we're going to be talking about a couple of things. We're going to talk about DSLs, we're going to talk about Sprout, we're going to talk about contracts, type information, and the future. So as I'm speaking, I want to call out a couple of questions I want people to think about and think about how they would answer these. How do you tell a client that a string contains HTML? How do you know if an API will crash your app? Closer. How do you know if an API change will crash your app? Hopefully your API isn't crashing your app by itself. But and so how do you experiment on big things like a redesign? So just think about those as I'm speaking, and we'll go from there. So before I get into the tool that we're building at Etsy, I want to give a little bit of an introduction to domain-specific languages, or DSLs. DSLs are really important in Kotlin. The language is really well designed for it. So who here has actually written a DSL themselves? Okay, so a couple of people. So that's great. So I'm just going to give a really fast overview. They're a simplified mini language. They're declarative. They can be data, function, configuration. They're perfect for a builder pattern. There are lots of tutorials online, and they're actually a lot easier to build than you think they are. I think most people can learn how to write a DSL in an evening or an afternoon. Who here has written extension functions? So almost everyone. Who here has written a Lambda? I should hope that a lot of hands for that one. You guys know how to write DSLs. Those are the two building blocks to a DSL. And so I'm going to give a really fast overview because I think people kind of shy away from building DSLs because it looks a little harder than it actually is. Essentially, DSL is just that. It's an extension function lambda. This is often described as a lambda with a receiver, so that you'll see in JetBrains documentation, lambda with a receiver. So we're all familiar with an extension function. When I say receiver, it's not anything crazy. It's really just this part of it. It's the type and the object that you're operating on. And so when you look at a lambda with receiver is really just a lambda that is operating on something. So it has a this. Whereas this is just a regular lambda. This has a this. So let's see what this looks like and do a really fast tutorial. And we're going to make a cat DSL. So let's start with a class called cat. And we'll put the type of the class as a variable. We'll add a top-level function called cat, and this will help us make our DSL really nice and just make it look nice to instantiate a cat. And so you can see there, this is your lambda with receiver. So the receiver type is cat, and the parentheses unit is the lambda. So what we do with that is we can just apply it, we can instantiate a cat and apply the lambda to it, because we know that lambda is made to operate on an instance of cat. So what does that get us? So that gets us a DSL that looks a little something like this. You can instantiate a cat, set the type to tuxedo, my favorite, and that's it. That's all you need to get your very first DSL up and running. But let's do a little bit more, because there's single instantiation is not really all you need. You need a little bit more than that. So let's imagine we want multiple cats. So we'll create a class pets, and in that class a list of cats. And we'll go ahead, just like with our cat top level function, we'll create a pets top level function. We'll instantiate pets and apply our lambda to it, and that gets us something that looks a little like this. This is not great. Sorry, I can't really hear myself. So this is not great because we haven't really created a list of cats. We want to have multiple cats, and now we just have a top-level pets object, so we want to take this a little further. So let's go back and look at our pets class again, and we're going to add a method to it. We're going to add a method that looks a lot like our original cat method, and we're going to, instead of just instantiating a cat object and applying the lambda to it, we're going to do that, but we're going to also add it to our list. And that gets us this. And now we have what's starting to look like a real DSL that you've probably seen in other languages. So there's one more thing that we can do here to clean this up a little bit. So if we go back to our pets class and we have our cat function, we can actually turn our cat function into an extension function on pets. And then we can make pets as simple as it was when we first created it. So we move it over, we have our cat function as an extension function on pets, and it does the same thing, and we end up with the same DSL. So this is a pretty common pattern. I just wanted to go over this section to just sort of teach people that this isn't really that hard. You all can do this. So let's talk about this library we're building at Etsy. It's called Sprout. Is it not animating? Oh, there we go. It's not animated on my screen. I'm sorry about that. So what is Sprout? Sprout is an internal library we're developing at Etsy. It's a code generation pipeline utilizing a custom Kotlin DSL to represent the nexus between platforms. So this is just a fancy way of saying it's basically this. Anything you have with machine-readable metadata can be brought into the DSL, and then we use the DSL to generate code for Android and iOS and whatever other platform. So before we get into this, I just want to answer the question, why Kotlin, really quickly. So I was inspired, last year there was a talk by Laura Kelly, who's an engineer at Airbnb, who gave this great talk about this Kotlin DSL they're using to do dynamic layout in their apps. I highly encourage people to check it out, but this was part of the thing that sparked the idea for this library to me. But most importantly, we use Kotlin because it's discoverable. Code completion and type safety help our user discover what is possible in our DSL. So on Android, we're all pretty familiar with this. You know, the code completion when you hit Control-Enter. If we have our own custom DSL, this is a great way of teaching people what's possible for writing appropriate types and calling appropriate functions from within that DSL. It's also really easy to read. So the syntax of a DSL is basically equivalent to the syntax of JSON. So if you look at these two things together, really the control characters in Sprout are pretty much the same ones as in JSON. And then finally, there's an easy separation of logic. So our extension functions can keep the DSL clean. So one of the reasons we looked at that, moving cat out of the pets class, was because that was a nice way of separating it. So different clients can have a different view of the SDL, and they can do different things on it based on private extension functions. So again, this is the cat lambda. So, but let's get back to Sprout and what it does. So I'm going to go over what it looks like first, just to give people sort of a mental anchor. There are 5 main parts to Sprout. There's a seed, a resource, a printer, a template, and the command line tool that makes it all work. And we're going to look at the code for each of these. Don't worry if you don't understand it just yet. The idea is just to sort of get people a 30,000-foot overview and a mental grounding on what's going on here. So let's look at the seed. So first of all, the seed represents an API endpoint. And essentially, the important parts of our DSL are this. You can just see that like we're calling this endpoint. API engineers would be immediately familiar with route and get and result type and things like that. And the next most important thing is a resource. So a resource is a concept in REST. It's sort of this machine-readable definition of types, structure, nullability, and optionality. We'll come back to resources a little later, but this is what our resource looks like. So our printer is basically what takes our DSL and generates code for our platforms. So in this case, we're actually generating Android models. Again, don't worry if you don't follow along what the code is doing here, but essentially it's doing a depth first search and like reading all the resources and generating Android models. And then finally, there's a template. One of the things that's so nice about Kotlin is that it's a great templating language. When I first built this tool, I actually started with Mustache and Handlebars, and I realized that I didn't need any sort of third-party library. With multi-line strings in Kotlin, you can do this right in Kotlin, and it's really easy especially using extension functions, to make sort of partials, what they call partials, which is just a concept in templating. And then, so finally, we have a command line tool. As this is playing. The most important part of a command line tool is lots of ASCII art and emojis. So make sure you put in ASCII art and emojis in any command line tool you ever make. So now that you have like an idea of the pieces of it, let's talk about what we did with it. So the point of this tool is that it's a pipeline, but I'm going to talk about some of the things we put in the pipeline as the first items. So one of the first things we did was to create what's called an API client contract. This is not the same as Kotlin contracts. This is sort of an agreement between the client, the native apps, iOS and Android, and the API in terms of like what the structure of the response or the request look like. So the structure of the JSON. So basically you want to know the structure of your JSON so you don't crash when you're parsing it. So let's go back to resource again, and we'll talk about the definition of, because what's being done in this contract is we're actually reading the resource. So it's the definition of the structure, type, nullability, and optionality of a REST API request or response. Roy Fielding describes it as the key abstraction of information in REST is a resource. Any information that can be named can be a resource, a document or image, a temporal service, e.g. today's weather in Los Angeles, a collection of other resources, a non-virtual object, e.g. a person, and so on. And in case you don't know who Roy Fielding is, he's one of the principal authors of HTTP, and he basically invented REST, representational state transfer. So he knows what he's talking about, but I like my definition a little better. To me, a resource is a unit of that API stuff. It's the stuff. So I go over this a lot because the resource is sort of what we're using to build our contract. These are the terms we're agreeing upon between our native apps and our APIs. So it's the request and the response, it's machine readable, it has properties, so like a string, int, long, or boolean. These are often called scalar types. It has sub-resources, it has cardinality, and it has the structure, type, nullability, optionality. It's basically what your JSON would look like. And cardinality is just the number of elements in a set or other groupings, so you could have 0 or 1, 1 or many, 0 or 1 or none, you know, stuff like that. So let's look at what an API resource looks like. So this is actually from Etsy's API. It's sort of a simplified example of what a resource looks like. And you can see it has properties and sub-resources. So in this case, this is the main response from an endpoint where we're comparing listings, but it has a couple of main properties, but it also has another resource within it. And like, notice that you pass this resource spec into the function. That's sort of the machine readable component in our case. And so this is specific to Etsy's API, but this should be a concept with any REST API. So it doesn't really matter that this is PHP and we're doing this in PHP. The concept of a resource is very universal. So almost everybody's APIs, unless you're doing GraphQL, will have something along these lines. And if you don't, bug your API engineers and tell them you need something like this, because it's very important. But when I said notice the spec, I wanted to point out that this is sort of the machine readable description of that resource. So I kept sort of harping upon machine readable, and here we pass in that resource spec def parameter, and this is what comes out. So this is a very simple nested array that shows us the name of the parameter and the type. So what we do on Sprout is we build something very similar. On Sprout, we have properties and resources. And if you look at them side by side, you should start to see that these make a lot of sense as the same thing. They're just the same thing and written in different languages. So what we do with this, though, is because we can make these two output, we can take our Sprout DSL and we output PHP code that looks like what comes out of that def object, is we're able to diff them against each other, and we're able to run this from the command line on CI. So because these two arrays, the one on the left represents what the native apps understand and the structure of that, of what they can handle. And the one on the right represents what the API is sending. So we want those two things to match. So if we diff them, then we can determine whether something is missing from one or missing from the other, and whether or not our apps are going to crash. And you can run this from the command line in CI. So again, don't worry that there's a lot of code here, and this might be a lot to understand, but what's going on here is we're walking the tree of that array in the previous slide, and we're checking to make sure that everything in the other tree is the same as the one we're currently walking. And we do that in both directions, because sometimes something can be missing from one, sometimes something can be missing from the other. So again, what we do is we run this diffing on CI. In our case, we just did this in PHP, but you can really do this with anything that can run on a command line. So in our example, all you really need to do is exit 0 if the diff passes and all the things match, and exit with 1 if they don't. One of the things we also do is that you wanna when developers hit an error and they come across a mismatch, you don't want to make them get stuck. So you often want to give them a link to a runbook, a little help document, show them what happened and what's missing. But if things went right, you can show them a little cat emoji and make them feel better. So this runs on Jenkins, and why is this important? Why would we want to do this? So it turns out API engineers actually really appreciate this. They appreciate static analysis tools just like we appreciate lint on Android and things like that. When the computer can help catch a mistake, it's saving us time and money. And so, when you have structural mismatch on our apps, things don't always go as you hope. So maybe you're this little JSON parser and you're running along and things aren't as you expect them, and it just, so we don't want that to happen. So let's move on. So that was one thing that we put into our pipeline. But I want to put a second thing into our pipeline, which is really generating the models for Android and iOS and giving them type information that are coming from our API. In our previous part, what we talked about was just reading from an API and then generating a contract. So in this case, the contract's not particularly helpful unless the apps are also adhering to it. So, with that contract in place, we want those apps to adhere to it, and we do that by generating code to do the JSON parsing and the models and things like that. One of the things, though, is that when you send stuff through JSON, it's sort of this reductive, lossy format. JSON only has about 7 types. So it has array, object, and then the scalar types like int, boolean, string, things like that. So when you send HTML, our API understands that a string has some HTML in it, but when we send that over the wire to our native apps, we can only represent that as just a regular string in JSON. And our native apps might want to do a little bit more with that, but they might not know it's a string. And so the only way that they actually know is through sort of like a wink and a nudge, and hey, by the way, remember to render this as HTML. So it's sort of just word of mouth is how we're passing along this type information. Why is that a problem? So this is an actual comment in our code base, and it's one of my favorite comments, and I'm going to read it out to you all really quick. Attention. If you are parsing strings in a base model subclass, and I bet you are, for your own safety, use this wrapper. Don't use JSON parser value as string. Assume you want all your strings stripped of HTML escaped characters when delivered by the API. If you show a string in the UI without cleaning up escaped characters, it's going to look ugly. Mother beeping ugly. That's a joke about Mother's Day encoding looking like censored swearing because it happened to me. Unfortunately, this is the engineer who actually wrote this was here a little while ago, but he had to go meet somebody. But if you all want to meet him, come find me after. But I think this is really funny, but it shows how we were sort of relying on word of mouth to pass along this type information. So we ended up in this situation where we were basically afraid of our own API. And we started using this to escape the escaped characters in our code base. But what happens when you start doing that on every single string that comes through from your API, you start to get a lot of object allocations. This was actually discovered by my colleague Jeremy, who gave a presentation this morning. It was a brilliant find. But so what happens when you have too many object allocations? You start getting things like this. And these are always the most fun when you get an out-of-memory error while trying to throw an out-of-memory error. Unknown file, unknown method, no stack trace available. So it's not fun trying to hunt those down. But we were so afraid of our API that we started to get a lot of these. And we tried to figure out what could we do about that. And so one of the things we could do is not run that stripping code on every string, just run it on the ones that have HTML. And so we do that by what I like to call side channel metadata. So essentially what we're doing here is we're routing around JSON at compile time and passing along little type hints to our native apps so that they can have like an HTML model or an HTML resource. And so how do we do this? So we read into the DSL like we did before. So just like this, and we actually recompile our DSL as we're going. So we try and make the system self-learning. So it turns out our DSL itself is actually very machine readable, and we can generate it, and we can add types that we haven't seen before to the DSL automatically. So this makes it developer friendly and helps adoption. So what does that look like exactly? So in our DSL, we have these types of functions. So we have these concepts of properties. So before we had sort of string and int in the DSL, but now if we have HTML and ID, that changes our DSL from looking something like this to something like this. So if you've noticed there on the first slide, we have int, string, int. in this slide we have ID, HTML, ID. And so this just makes it a little nicer for our DSL. It can read information we already have in our API, and it can pass that along when it's doing its code generation for the native apps. And it does that through these functions, which are very machine readable. And as you can see, that's actually a slide we looked at before when we looked at templates, was one of these functions. Because they're very consistent, they always show up the same way, they're just boilerplate, so it's very easy to write them out and read them out. So what we do is we read from the API, we recompile, and then we get something like this where we can route around. But how do we do that? How do we actually route around? It turns out, like, just because we have new type information doesn't mean we have a new object. So we don't really want to change the structure of the JSON response. So we don't want to change the models, but Kotlin opens a really awesome, huge door for us by giving us type aliases. So type aliases are amazing. Type aliases are assignment compatible, and they don't actually act like, they get basically erased at runtime, but they give us that little bit of information when we're developing, so that we can treat our HTML like HTML. So that when we generate our code, we generate a model that looks a little like this. So you can see that positive int, those are type aliases, and really Moshi just sees that as int, and it totally works with Moshi. It gets erased at runtime. Moshi doesn't care about this at all, but what it does is it gives us something like this. It gives us IDE hints. And if you look on the left is actually the type alias, and on the right is the actual type. I seem to have lost my speaker notes, sorry. So type aliases are great because they can be used on iOS and Android. They don't change the structure of the JSON, they're assignment compatible, and they provide a hint to the engineer working on native code. But wait, there's more. So again, like, I want to go back to this concept of this is a pipeline of code generation. So one of the things that we want to do is we want to sort of look to the future and think about other things we can put into this pipeline. And basically anything that is machine readable makes for great metadata. So it turns out that styling information actually makes for great metadata. It doesn't change that often. It's not something we necessarily want to send over the wire to our native apps. But generally it seems like it's too big to be experimental. So if you don't want to redesign an entire app, you're going to want some way, some sort of pipeline to do it in small bits. And so by putting it into our pipeline, we've created a way to do that. So we're going to look at this is still under development, so I don't have as much on this, but we're going to look at a really quick example of how this might work with something like Figma. So this is a response from Figma's API, and something should be jumping out at you. Styling makes for great metadata. It doesn't change too often. It's machine readable and writable. And it's when you redesign an entire screen, that can be too much to experiment on. Being able to put this in a code generation pipeline allows you to break it up in a way that you can experiment on it. So I want to look at a little example. This is still under development, so I don't have as much on this. But we use Figma at Etsy, which is a web-based design tool. This is a Postman response from their API, and something should be jumping out at you already here. I've talked a lot about machine readable, machine writable, and you should already see something that's very clearly something we might want to use in our apps to put some styling information in there that we wouldn't send over the wire, but that we want to be able to have and be able to experiment on and just use in our apps. So this is important because while we use Figma, everybody has an API these days, whether you use Sketch or Photoshop. They all have some type of scripting system that you can get machine readable data out of them, metadata. What you get will differ a little bit, but they all provide an extreme amount of data. I want to talk a little bit about Jetpack Compose because I think it's going to eat the world. It's going to be a huge game changer. I'm really excited about it. Mostly because it starts to make all of this even easier to read and write. Compose represents styling information in code. So I don't know if you all have checked out the examples. They have this great material theme.kt in their Rally app. They use Rally app to demonstrate new features. And if you've checked out Jetpack Compose, you can look at this file. And it should be jumping out at you already that this is very machine readable and very machine writable. And why is that important? I keep talking about this, but and how do we experiment on that? If we were to do that under Android's current theming system, this means a lot of XML. This means res values. It's not the easiest thing. You can switch them at runtime, but it gets kind of tricky, and it's not the easiest thing. So when Jetpack comes along, we're going to be able to do something like this. So you set a feature flag, and you can switch between your snazzy theme and your swanky theme. I mean, really, your themes should be both snazzy and swanky. That's what I would recommend. But you can switch and see which one does better, see which one your users like more. And so this starts to get really interesting when you use things like semantic UI. So if we look back really quickly at this is actually using semantic UI, so it's saying primary variance, secondary variant. Basically, not hard-coding the colors, but hard-coding the importance of the color, where it's used. So semantic UI and Jetpack Compose really go well together, and they open a lot of doors for us for experimentation and being able to put something in our pipeline. So that is just one of the immediate futures, but essentially what I want people to come away from this talk with is that anything that's machine readable, anything that's machine writable, these are great candidates as long as you don't send them over the wire to put in your pipeline. So even though it's a command line tool, you might ask, what about a UI? And actually I'm glad that you asked that, even though I asked that. So one of the things I did with this library is to add a little web UI, and I don't know how many of y'all are familiar with Queb. It's the all Kotlin library for doing rapid web development. It's this really weird little library that uses a thin client socket server to allow all work to be done on the server side in Kotlin. And it's a little strange to get used to, but it's great for rapidly prototyping. So the code ends up looking a little something like this, which is really nice because this can run in our command line tool, and it can understand our DSL because it's still in Kotlin and it's on the server side and it's part of our tool. And so it all works really well together. And while this is mostly just an add-on, you end up being able to create something nice like this. And this is something I put together in just an evening. And for anyone who's familiar with something like Swagger or Apiary, this should look pretty familiar. It's a nice little tool that can connect to our to our DSL and our command line tool. And it can make it really nice for your developers to just have a greater understanding of what's going on. So as I finish up, I just want to talk about some guidelines. I really hope people come away from this. 5 minutes? Okay. I really hope people come away from this understanding that everyone can build one of these things. It's all really easy to do, and it provides a lot of value. So when we were building this, we had some principles, some guiding principles and aspirations. We wanted it to be unopinionated. We did not want to impose complexity on existing systems. We wanted it to be easy to use and easy to learn. We wanted it to be designed to grow and designed to learn. We wanted it to be lightweight. So this is just running on the JVM. It's a vanilla Kotlin. There are no third-party libraries or dependencies except for that Queb, which was just sort of an add-on. And we want to put in runbooks for everything. So we want to, when our developers hit snags, we want to give them steps to keep moving forward. There have been a lot of efforts to do this in the past at Etsy, and I'm sure at lots of companies. These tools often fail when the primary developer is on vacation or they leave the company, and some developer is using a code generation tool and it hits an error and they don't know what to do and they just get stuck. So it's really important to provide runbooks, so you have clear error messages with those runbooks in them, and to just, you want to be able to do one thing at a time. So even though we started with contracts and then we went with types, we do have this grander vision of being able to do lots of things in the future. So, I want to dream big. It's really easy to throw lots of logos on a slide, but I think all of these things are possible. I know that other companies are doing some of them, and I've written out examples of some of them. But if we start with one, we can provide value, and we can harden our pipeline and then make it easy to connect more platforms. And so if we get to a future where we change to GraphQL, then it should be pretty easy to just switch out a few classes in our code generator and keep moving forward. And so that's it. Thank you for all the fish.